All right, in our last example for chapter 5, we're going to go over how to use an antiderivative for z to the negative 1/2. That's, of course, what this contour integral is doing, which is 1 over z to the 1/2, of course. And we're gonna look at where z is a line segment from z0 is I to z1 is 9. So if we were to graph this, which you should always do, here we have I, here we have 9. So C is that contour. Now, z to the 1/2, if you recall, is, well, it's only analytic on the same sort of principal branch. It's away from the branch cut for the logarithm function. So it's only analytic on the complex numbers with non-positive on complex numbers minus those that are on the non-positive real axis. So that's where this guy is analytic. And so similarly, 1 over z to the 1/2 is going to be the same thing, right? Because we're throwing away 0 as well. And C is actually away from that, right? So C, our contour, avoids that area. So we know that an antiderivative exists, and we can actually use the one that we know it is. So an antiderivative is going to of z to the negative 1/2. Let me just be clear here. Is the usual thing. It's 2z to the 1/2, and it's an antiderivative on the appropriate domain. Okay, it's not an antiderivative everywhere, but it's an antiderivative on the appropriate domain. So if we want to do this contour integral, we take 2z to the 1/2 and we evaluate from I to 9. And so we have twice 9 to the 1/2. Remember, we're taking the principal branch everywhere. So, we're taking the principal value everywhere. So when you plug in an integer, the principal or a positive real number, the principal value is just the normal square root. And when you don't, you have to go in and you have to do the cosine and sine stuff. Okay. So I'm not going to rehash that. What you're going to get is root 2 over 2 plus I root 2 over 2 when you compute the principal square root. The other square root is going to be the negative of this one. But we're going to get 6 minus root 2 plus I root 2 if we were to multiply that 2 in. Oops, minus I root 2 rather. If you were to multiply that root 2 in. All right, so again, although this was not an antiderivative everywhere, it was an antiderivative in the portion that we cared about. Now, if our contour, the last thing is a word of caution. If our contour was do something like this, if it was that guy, then we have to now all of a sudden be a lot more careful about using antiderivatives, because using what we think are antiderivatives, because this crosses sort of the portion of the complex plane that we're cutting out to use the antiderivative. So there would be a lot of caution that would need to be taken in order to do this orange integral here, or the integral over the orange curve here.